Hello friends. Before we actually dive into Jupyter Notebook and go through all the NumPy code, let's have this last theory section on array fundamentals. So as we all know that in computer programming, an array is a data structure for storing and retrieving data. We often talk about an array as if it were a grid in space, with each cell storing one element of the data. For instance, if each element of the data were a number, just an integer or a double, we might visualize a one-dimensional array like a list. So the very small difference between a Python list or an array is, or a NumPy array is, in the list, each of the elements can be different. For example, we can store a character or a string or a number in each of the different cells. But for a NumPy array, it can be all of the same data type. It should be always be an integer or a float for NumPy array to exist. So a one-dimensional array would be like a list where each of the cell we only have got one row in which we have got all these array elements. Similarly, for a two-dimensional array, it would be like a table. So it would be like an Excel sheet where we have got rows and columns, and each of the row and column, each of the cell would be representing one element of data. So in NumPy, this idea is generalized to an arbitrary number of dimensions. For example, we can have like 1D array or 2D array or an n-dimensional array. This is where the name ndarray comes from. Ndarray is n-dimensional. N stands for n, and D stands for dimensional. So ndarray, which is what we call for a NumPy array is ndarray, which represents an n-dimensional array. Now an ND array or an n-dimensional array, it can be represented same to a mathematical concept. For example, we might hear of a 0D, zero-dimensional array referred to as a scalar, which is only having like one value. Similarly, once we talk about the list, the Python list, which is similar to like a one-dimensional array, this is also called as a vector in mathematical terms. The 2D array is called as matrix. The one we just saw, which is like an Excel sheet where we have got rows and columns. That is a 2D array in terms of NumPy arrays. But in mathematical term, it can be also called as, it is referred to as matrix. Similarly, just to generalize this concept, if you're talking about ND array or an n-dimensional array, this is referred to as a tensor. So if you have heard about the TensorFlow or the PyTorch, this is where this name comes from. This is actually a mathematical concept which we generalize any type of n-dimensional array as a tensor. So just for the clarity, right, because we are learning NumPy arrays in this. So just it's better to avoid these mathematical terms when referring to an array, because the mathematical objects that we are talking about, for example, the matrix we are talking about, this is slightly different than the array, the 2D array that we'll talk about. For example, if we talk about matrix multiplication, which is a mathematical concept, that how we multiply two matrices, that is totally different than how we do the ND array or the NumPy array multiplication. So that's why I mentioned that it's best to avoid this mathematical terms when referring to an array or a ND array. So as mentioned that for any type of n-dimensional array, we can refer to as a tensor. So that's why many of the other scientific Python libraries that we have, for example, PyTorch or TensorFlow, so all these have got the fundamental data structure of PyTorch is the tensor, for example. So that's why we should be quite aware of this. And that's why I have always mentioned at the very beginning of this series is that NumPy is the basics for all the other higher level Python ecosystem or the Python modules. For example, NumPy is the basis for pandas. It's similarly for say math.lib and also for TensorFlow and PyTorch, SciPy. So all these libraries are actually the basics are actually just the NumPy array, the NumPy module which was introduced by in Python just for doing all this type of scientific Python ecosystem. So just to conclude this video, so most NumPy arrays have got some restrictions. I think we have also discussed in chapter 1, where we went about the details about the broadcasting and other details about the NumPy arrays. Just beware that, just these rules are there that all elements of the array must be of the same data type of data. And this is how the NumPy array is different from a list or a tuple in Python. And once created, the total size of the array cannot change. Also, the shape must be rectangular, not jagged. For example, when we're talking about this 2D array, 2D NumPy array, so here For example, in the first row, we have got 4 columns. The second row also should have 4 columns. It should not have like 2 or 3 columns. So all the rows and columns should be same. Okay, so because of all these restrictions, that's why we concluded that NumPy is very, very fast. Because once we have all these type of restrictions, for example, it should be always of the same data type and the array size cannot be changed. All the other like vectorization or the broadcasting makes NumPy very fast, and that's where it exploits all these like performance improvement, making it like very, very fast for all the other operations. So this was the last part of the theory. In the next video, we'll go to the Jupyter notebook where we have written all those. We'll go through all the NumPy operations and go through and show demo the actual code. So see you all in the next video.